It's later afternoon. I still want to thank the organizer invite me to here to the talk. It's an honor actually giving talk here. Hopefully my talk will be not put you into sleep. It's going to be a little boring. Plus, it's a long day, but I think the whole program is very exciting. What I'm going to talk about is totally different. Something that is not science, because originally it was asked for doing some science, but later on talk about products, realization. I thought it's interesting because as a student, when I was a student, I have no clue what the company works on, right? How you bring the idea into their products. So when I got this assignment, I actually was very excited. I said, hey, I can do something that hopefully has some meaningful information for you guys. And for example, even when I started FAT, I have no clue what FAT for. So, but these days, students is much more smarter. At least I look at it. Let me start with going to talk about basic outline is how innovation works, and then talk about how you make a product. Later on, when you have the product, how do you sustain and continuous the idea? Then I'm talking about the team, right? If in case that if you work for industry, you will be part of a team to work there. And the next one is, this is because a medical device company, so it's a regulated company. And safety and compliance is a must, right? These days is much more important than like 10 or 20 years ago. And then other one is, I tossing the idea is, if you work for a company, where you will be, what kind of job you can do, right? So let's start with the idea, right? When you have the idea, how do you bring this idea to this a product that can, in our case, imaging device? As a company, it's different from a research institute. If Simon has an idea, he just said, "Let's do this idea tomorrow," right? And give him some money. And in our case, it's not that easy. There's a couple of things that we have to keep in mind. In particular, I simplified. I like this one called NABC. Basically, you look at the needs and look at the what kind of approach, which means technology, and then what kind of benefits that can bring to you, and then the competition. So I want to go to a little bit of detail on that because this is a fundamental thing as a company have to start with. It's called a business, basically called a business rational document that you have to do that before you start a program. All right, and what that means in terms of need, by the way, the needs and I want is different. Usually that when we visited the doctor, say, hey, I want to this is this, but it's not necessarily that what he needs, because if I build it, I say it's cost $5 million. Oh no, that's not what I'm asking for, right? So you have to understand need, and then the approach is have to look at technology, feasibility, and have also different approaches. One thing that for a company being successful, we say you're looking for golden nugget, which means the key technologies that you can keep, and also the competitors have difficult to catch. Now these days it's all about same, but that's really the thing you have to keep in mind. I want to differentiate because breakthrough technology evolution. Breakthrough technology means something very new. Something new. Let's say if you're building a PET detector, and then now you move to PET CT, and PET MR. Those are called a certain breakthrough technology. But evolution means you continuously improve. I have a reconstruction of filter back projecting style, then I have iterative, and then I have a point response function that improves my image quality. That's called evolution. Disruptive, that is something great. And I'm not sure in nuclear medicine are there any disruptive technology I've seen it. This one is called disruptive, right? Before this happened, Motorola has a big called a laser, the laser phones was so good, everybody wants it. But after this coming out, Motorola or even BlackBerry basically died because of this disruptive technology. So you have to keep the approach in mind. And then customer benefits, not only customer but companies. Then competitions. So those are things you have to keep in mind. Now, to make a product, you have to start with some ideas. So there's exploratory and research stage, there's advanced development phase, there's products development phase, and then the actual clinical use. So these are steps that you have to go through that. Exploratory basically the idea generation, high risk, high gain. It's similar to academia. You look at things, but it's more strategic and long term. Right? That's called exploratory. In terms of advanced development, that's what I'm, in my domain area. We look at applied research, which means early technology. When you talk to me, hey, Ling, the company likes this idea, I will look at it using my own judgments. The success rate is probably 80% or 70 to 80%. Then I will jump on and try to do something. If it's 50%, I'm not going to spend money there. I'm still going to be in this area. And then, so that's the key thing. And then we do a risk assessment, right? And try to do in research collaboration with you guys, like institute. Products development, in certain way, is very boring from you guys' point of view because it's no longer it's less innovation. It's really actually a defined intended use, what technology already used. For example, if you have the PEDMA device already, you have the laboratory device. Now what you do is make sure that works in the clinical setting. And it's a workflow. It's engineering implementation. More importantly, it's talk about safeties, reliabilities, because you don't want to build a system that going up and then you have customer calls, oh, it doesn't work. Now, it happens quite often these days for the companies, but you want to minimize it. And then it's the manufacturability. Amazingly, especially for scientists, sometimes don't think, because I hired few scientists, include people from here too. When you put a task there, they only thinking from laboratory domain. They never think about a technology holds, or even a high school student has a certification, right? Want to operate that system. They don't have your depth of knowledge. So you have to taking care of that into consideration when you're doing a design. And the other one is serviceability and sustainability. Those are very important too, because how do you sustain your product? If every year you try to spend lots of money, time, to effort to modify your system, you're going to lose the business. So, and then compliance regulatory is must these days. And then when the system works, now you put this into the clinical user's hand. And what they do is they give you feedback, it's good or bad. And then they also using their innovations, which means they say, aha, I got a washing machine. Besides wash the clothing, can I wash potatoes, right? Can I wash my cat? They have their own creative ideas, but you need to think about it. And then that's what the clinical science coming in, right? And then you have the bugs to fix. Let me just little bit summarize what I just said. In our term, we usually call it technology tunnel. Tunnels. You start with lots of ideas, and then you funnel into a tunnel of funnels, but you go into smaller, and then in the product, you actually have much fewer. So I think in Silicon Valley, you guys probably heard of there's lots of startups. Some people like work for startups, but the reality is only 10% of startups actually will be successful, make money. 90% of them will be die in year or 2 years or 3 years, right? So it's the same thing. You will start with new ideas, but eventually you will have few passing through it. I want to give you an example of that, which actually personally I did it in terms of how I started a new idea to technology, but it didn't fly. Oh, actually, we made a business decision. We're not going to go through that. One is about 7-8 years ago, we started the idea of can we make a dedicated cardiac system, right? So what we did is similar way to you guys do is start simulation and define the geometry simulation that looks nice. And when I got some encouraging data, then we started up the mechanical people can put something together, right? So that's what we start the drawing design and then put things together. And then we further pushing, okay, could I put it into a more system looks like, right? So, and then in order to show these things to management, I take an additional interesting step, a small step, but interesting step. We actually put a carton box that had nothing inside, but want to define the system, see how it looks like. It's important. So my technician put that thing together, and that was quite a few years ago. You can see I'm much younger at that time. And it's actually, if you think about the whole thing, is what exactly GE did. GE's the CZT detector system is exactly that. Unfortunately, I did not patent that idea, so I cannot chasing GE at this time. But we decided at that time we're not going to pursue because we have other more higher product projects that we're working on. So let me go through a little bit more into more products development. Remember, on the beginning, I have research, advanced development, products development. Inside products development, actually FDA is demanding or really what you call is a regulate medical device company have to go to called phase. It's important. Phase. So first of all, you have a products proposal. After proposal approved, then you define what scope of the project and the planning up. Then you do a design implementation. After that, you do verification, and then you do validation at the site, and you start ramping up. You transfer that technology from engineering to manufacture. Remember, inside manufacture, most cases, all the assemblers, technician or high school graduate, right? They are very good following instructions. They're very good, probably better than all of you. And then you have to write the instruction very carefully because if you write wrong, they will follow it wrong, right? So that's what the products definition is, and the important things that differentiate from there. So here's another example of, I want to say, is quality of work during design versus requirement in planning, right? This is an example of our spec Bravia XCT system. So these are the spec detector, and this is the X-ray flat panel. Similar what the previous talk that gave it in terms of flat panels. One thing that is a very typical model in terms of how you define your work and planning. There's two types of work style. One is you define your products very well, and then you start working. In principle, that way actually finish fast, and you actually have minimum resource. Other one is, let's start work, but without understanding what you're working on it, and start buying things, and that one doesn't work, then we buy another one and try out. And eventually, your spending of money is much bigger, and then your time goes much slower. So there's a little bit art going on in terms of how you manage the products. Another example is we are medical device companies, right? We have to get in some patient data that when you're acquiring data, our system, when you're building systems. So you have to be creative. All right. For example, one of the things that we did recently, we are developing a digital PET systems. What we did is we have this. This one is our PET CT system. Luckily, between PET and CT, we have a separation. Right? So what we did is we actually already built a ring, detector ring, that we can slant into back and forth inside there. So now when you're doing a standard pad, and then we slant in into our sort of a technology assessment. And that's what exactly we did at the Universal Hospital in Cleveland, and try to demonstrate our current technology and this new technology. And that's an easy way of you to getting there. Otherwise, if you're building whole system like your original did, that's going to take much more effort, right? So the innovation, my point is the innovation is not just the technology. Innovation also talk about how you're planning your whole things from your product's design point of view. Let me go back to the product design again. Remember, at the very beginning, I say the product has to have the breakthrough technology evolution and also the disruptive technology. So if you look at it from overall technology development, you always have continuous exploratory research going on. Especially for the big company like Philips, GE and Siemens, there is a dedicated research teams going on and looking at that. And then we also have an advanced development, project going on all the time, just looking technology. Is the technology, the research, technology mature or not? And try to put it into the pipeline. But then when you're doing products development, when you're finishing products, you're sustaining and then you improve and sustaining. And one day you say, you know what? I'm going to end up manufacture, which means I'm going to stop making that product. But that does not mean you wash your hands, talk to the customer, say, I'm no longer responsible for this product. You still is, regardless what the situation is. In fact, these days, FDA put a very restricted guideline. Even you see my product's end of life, if the customer is still using it, they don't care. If the system have caused some, basically some human, especially as people hurt or even in some cases could die because of the system malfunction. As a manufacturer, you're still responsible, and that is currently in certain way really make a manufacturer's life much tougher, and the compliance has much is becoming a number one issue. So when you have this products going on, then at some point your new products coming in, and then you go through the same cycle again. So here's who's making such products, right? It has to be big team. It's no longer just Simon and his lab anymore. It's going to be a product team. So it's a pretty big team, and we call it a cross-functional team. All right, and this cross-functional team, we have marketing team, program and offers, R&D, regulatory affair, quality control, customer support, and manufacturing. All right, and marketing, as you guys probably know, just getting the customer feedback and then what kind of products we should market and then so on. Program manager offers actually they define the scope of project according to marketing need. And chasing you, say, hey, are you there yet? What's the schedule? R&D is a core, definitely, but it only provides technology. It's only one piece of input. And regulatory affair right now has biggest to say because they could say stop shipping, and then the whole company just freeze. They have such power these days, and so. They have everything we ship out, everything that in our contract, they have to take a look at. Quality control, it's to talk about how you make your products is, up to the quality. And the parts, when we buy parts from vendors, we have to qualify vendors, make sure that they are in control too, because otherwise, if there's a problem, it's incident. You guys probably hear less from medical point of view, but hear like airlines, right? When the airlines crash, they will look into every components of it. They will go back to the airplane, what's going on and so on, right? And then that's quality control people have to be involved. Then customer support is easy for you. The manufacturer is also understanding, purchasing and so on. And I sort of give you a little bit high. If the team form, what's the scale, scope of people involved? R&D is big. There's no doubt. Everything has to be done physically, but then each team has different involvement. After the manufacturer here, I'm talking about only the people who are going to receiving the manufacturing, receiving the device. It's not include people actually put things together, right? So this team is a manufacturing engineer or people that are going to be involved. Say, okay, you have defined products now. Let me take this to my team, and that's the team formation. About that kind of scope here. Let me touch a little bit into more compliance and safety. And then the first one is number one, FDA compliance. You talk about quality system. I don't know whether you guys, I think in medical school you also have a quality system, something like that, compliance. But basically called the 21 FCR 820. That's mainly the document. The document actually is very thin. It's almost like the booklet you just gave to me. That's the program booklet, probably about 15 pages. Very, very scripted. But so it's very simple. But then in terms of actual paperwork, it's huge. My engineers right now, it's probably spent 40% of time, I don't want to scare you, but 40% of time on the paperwork, or even more. And then only 60% time doing real work, like when I say real codings, science calculations. But that's the reality. And then, so that's, then the other one you probably heard called pre-mark approval from FDA, it's called 510K, which means before you sell a system, before you talk to the customer, I have a system that can sell to you right now, you have to get this approval. Then you have a quality systems, right? And the quality system is a process, basically is guidelines that you have to follow, right? And in certain way that if you go to the company, usually from FDA point of view, if you don't write down, it never happens. Right? So in other words, if I say I tasted, well, if you don't write down and tasted it, regardless how many times you tasted, it never happened. So when FDA come in and say, here's the risk, how come you don't taste this? You say, well, I have 3 engineers tested half a year ago. Where is the document? If the document doesn't record it, it's never happened. So then the key things these days are they very much emphasize on the management review. What that means? That everything happens. They take the manager as a responsibility. In other words, they really beating hard on the make sure the management takes the responsibility, and that's important because especially for the general manager or CEOs, they want their job is making money, right? So they, in lots of ways, they say, let's ship the products, let's do that. So they put a pressure on this. So if they say, you guys are responsible, anything happens within the company. That's the truth, right? And that's the truth. So management, but it's interesting. You guys probably heard of executive teams, right? Executive team CEOs and COOs, CFOs. Since you guys are all technical person, so I'm a technical person too. Typically, as a technical person, don't have any voice on the executive level. You just a sideline. They make a decision. It's a business decision, and sometimes you get frustrated because some decision doesn't make sense, but they make anyway from their point of view. So that actually it's a lot of engineers. When they go to work for company, it's whether it's real, whether they just perceive that way, which means sometimes get frustrated. How come I know exactly going on? How come they didn't work that way? So this is usually the gap between the technical people and the executive team. Risk management is very important. Document control. design control. It's called a design history file that you have to document how you actually design for a system. Right? All the paperwork has to have traceability because if there's an incident happens, the FDA will look at all the traceabilities. In particular, in the manufacturer, called the device master record. That basically for each device has a history of how that system put together. What's the testing results? And then it's like patient. It's like you go to doctors, you have patient history file. Actually, doctors these days, if you go to different doctors, you have different history file. But for this one, it's just one master. And then you have to keep in your attic. In the old days, it's basically somewhere on the corner that you put it there forever until that system is basically out of commission, out of a hospital. Otherwise, you have a legal responsibility to keep this there. And then the complaint investigation, it's called CAPA, Corrective Action and Preventive Action. This is very important, in the, which you guys probably haven't heard from academic point of view. It's very important. In other words, if there's a problem in the field, you have to take action within certain days. It's a law. You have to take the action within in our case, 90 days. You have to make a decision what you're going to do and so on. And then you heard of lots of other, acronym ISOs, IECs, and these are just ISO 900 is for the products. ISO 901 is for the organization. It's a process for organization. ISO 2003 is for the operation and software. So there's so many things that you have to follow. It's getting boring, but that's the life. And then you have the other certificates you can do. And then safeties, that you have to do all the safety calculation and so on. Now, the last one, what I would like to do is basically give you a little bit of overall organization structure you come up for the talents or people like yourself. One day you want to go to work for industries like myself. And after a few years in academia, I decided to go to industry, which so far I'm enjoying it. It's a different thing. Everything I'm doing is similar what you do, but the emphasis is different. So in the corporate research, most of the scientists that go in there as PhDs that go in their corporate research. For example, Philips, we have two major corporate research. One is in New York, Brighton, and the other one in Germany, and also in Netherlands. For the medical device research, medical imaging research, most are in Germany. So if you want to find research work in Philips, you need to go to Germany or Andover. So it's Amsterdam, right? So that's the potential. And then the GE, Siemens, actually Siemens probably combined together, but GE has a similar situation. And then called research and development. That's more engineering. Then you also have scientists like myself. I'm in R&D this category. I'm in R&D this categories. So you have some PhDs, and you also have masters and bachelors. In particular for core technologies, like say nuclear medicine, the core technology people understand usually PhDs. But that's only, I would say, only 10% of our R&D team. 90% of people are just mechanical, electrical, software, and all the documentation, mission, everybody adding together. And that's usually the skill set that a master and bachelor degree are needed. They are talented in different ways. They are very good implementers. You're designing things. I don't think I can do a good job like them. It's just different way of wired. Then the manufacturing engineering. You also have some pretty talented engineers there too, but they are more doing the sustaining. In other words, the products broken or doesn't work, or I want to source in different parts. Let's say I want to change the X-ray tube, right? And then they will go in there testing and make sure the tube is still the same, every specification is the same compared with the original design. And those people are involved. But amazingly, I think that these days, it's special for the big companies. They also have PhDs working on manufacturing because I think they, especially the top companies, they have lots of people want to come in, and they just recruit. They sometimes abusing the resource and talents, and those people work for a few years and then left. That's normal life. And then I want to summarize, give you some idea of, I call it yourself as a research institute and then industry. So in terms of different area of work, like I mentioned, exploratory research, industry actually do less, academia is do lots of, right? And then for advanced development, then industry do lots of it. You guys do something, and in particular collaborate with industries. And product development, you guys don't do it. But actually, I may say it wrong because Dr. Bong actually is making something. But post-release clinical science, the industry do, and you guys actually do because you're helping the industry to work in this area. So that's the high-level summary. And this is my last slide. Just want to summarize. To bring a product to clinical use, you have to have the technologies ready, and then products has to meet the needs. And then engineering has to have a competency to implement it, and regulatory compliance and marketing strategy. Because if you have a good product, you don't have marketing strategy, sometimes it's very difficult taking off. And then to be successful in the marketplace, when you have the products in marketplace, the product has to be competitive in technology, has to solve the clinical pain, and the cost has to be there. Then easy use, reliable, easy to sustain, and then you have ability of a continuous to be improvement. I think that's all my talk today. Thank you.
So, in your technology tunnel, where you have the idea to the person, where does most of the technology die in that time frame? Is it cost? Is it need? Is it manufacturing?
I think you mentioned everything. So it's usually the need. Is a need there, right? And then second is cost. Whether the cost makes sense. Those are two things that really driven. And it's from business. When your cost are involved, it means business justification. Right? For example, you guys probably heard the CCT detector for a long time. We talk about CCTV there for spec. That was for the last 20 years we're talking about, never tried. GE took the effect and the efforts to bring into their cardiac system, but I think that their system is so expensive it's not a mainstream. I think they have difficult to sustain. Sorry.
Can you describe a little more what the difference between the corporate research and the research or the research and development you had on one slide?
So corporate research is really similar to what research team you have doing that. So their job, they in certain way, there are three revenues where the money comes from. One is I call the tax money from company, which means company like Philips, they dedicate a certain percent of money, just want to make sure that we have innovation going on. So that money goes. Then they try to contract. So they can solicit to me as a R&D, say you have any technology the development you want to look for me to look at it, and I may say yes, I want you to look into here, and here's money. Other one is grant application, similar to you guys' situation.
I'd like to pick up on the word disruptive technologies that you used. My impression, I underline the word impression these days, is that the large companies, Philips, Siemens, GE, other large companies, actually are not that interested in disruptive technologies. but they're worried about disruptive technology.
You are right. It's not saying they're not interested. They simply don't have the mind.
I just want to pick up on one example of a disruptive technology, which, if I remember correctly, was actually Philips, developed by Philips. Was digital music, the CD.
Yeah.
Now, as far as I can see, the large companies these days wouldn't be doing that anymore. Can you comment on why? Is it just business pressure that this kind of research is now not done anymore in the large companies?
I think I think you're right. In fact, because I've been reading those books in terms of small companies and big companies, the challenge is Wall Street put the company into so much pressure that if you don't get your number tomorrow, next quarter, you can die down right away. And that's number one. Number two is if you look at most CEOs of big company, they only look at for their couple of years because 3 years later or even 2 years later, they don't know they're going to stay in that company or not. So why should I look into that? And that's I think that's the sort of mentality which is really not good ones. Philips is actually much more in terms of long term because Philips company mothership, I call it mothership, is in Netherlands. They have a little bit more longer term because they want that. So they are, both. It's their board of directors try to force in that direction. So that's why I call it. We still have tax money, and we have been going back and forth. In this year, we have Philips made a decision that tax money that I talk about from corporate, they're going to be free to the research. In other words, the research team can define their own topic. There's no demand that they have to do something that make me happy or make the products development happy. You can think two ways. One is say, well, wasting time because now as people start dreaming that things that not necessarily help me. But on the other hand, exactly as you say, if they hit like CD, that's tremendous. Philips made money on that CD. That's even though right now CDs no longer exist.
Can you comment a little bit on the hiring sort of, it's sort of been exponential I've seen recently, the hiring of PhD scientists out of graduate institutions as postdocs in the industrial world versus in academia, where this is traditionally reserved for more academic institutions. Why you see corporations go into this trend?
I'm sorry, you say the corporate also going to postdoc too?
No, hiring PhD graduates as postdocs rather than as R&D scientists versus, this is a typical path that most people would take if they go into academia, but not to industry.
This is a very sensitive area, and I don't want to disappoint you guys. But since I'm a very open guy, so and whatever I talk here, stay here, right? Because recently that I see an article that coming from one of Cornell student. She is PhD in neuroscience. She wrote a book about. Basically, wrote an article on the website, basically saying, these days, postdoc is misused. Right? In the sense of, those people are talent. If they go to industry, they will pay more money. But they in the lab, it's different story. And I think, to me, is in certain way, it's called a demand, need and demand. Right? If the industry hire a person, I will feel not in norm or feel guilty or even have a difficult to hold that person if I hire this person as postdoc. Because when that person comes in, that person can truly help me for product development compared with other teams. Other teams like the bachelor degree or master degree. The PhD can be more product in lots of ways. So I cannot hire them. It's unfair. It's unfair to that person. Right? That's the industry standard. So that's why usually we don't hire because otherwise you will be emotionally upset. why I'm playing that role, right? But in the academia, that's why I'm put mask here. But academia is a different scenario because there's so many demands. There's not much demands in academia. In particular, if you want to stay in academia, being a professor like Simon later on, having asked Simon's name so many times today. Hopefully he's not going to kick me out. It's different. So you sort of go through your postdoc period, right? But for example, and I was lucky. In 20 years ago, that scenario is much less. So I didn't go to postdoc. I go to University of Pennsylvania right away as an assistant professor. So it's different. But I think the other things, since I have opened my big mouth here, as a scientist, you have to think in big way. You have to think in big way in terms of whether you enjoy what you're doing. If you enjoy what you're doing, then it's fine. But if you think you can you want to do it, much more diverse, then you go to industry. But at the end of the day, I think the industry is much bigger than academia. I give you an example, and this is good or bad. But 2 years ago, I'm working for Philips, right? 2 years ago we have a big Philips, this plan or research group in San Jose. They decided to shut down. I was worried about the people working for me. Are they going to find a job? Luckily, everybody find a job. Right? Every find a job actually find not bad job. For example, some people go to one person go to digital pathology. Right? In other words, these days that you have in the old still using when you're doing pathology, you have to put glasses, look at it, you microscope, and then you store into a what you call the storage area. Now they do digitizing. So, but digitizing this, there's lots of technology which is similar to what you're doing.
So sorry to cut you off. I'm sure you have time to stick around and any more questions.
Okay.
We want to thank you so much for coming and have this for you.
Oh, okay. Thank you.
Do you mind taking a picture?